Hello everybody, this is Mr. Bowman. Today we're going to be looking at calculating probabilities with Venn diagrams. So we have a recent study, apparently, that medical researchers surveyed Americans about their diagnoses of 3 lung diseases. Researchers acquired their data from a health and wellness survey of 75,000 Americans. So it looks like there was 70,345 of our 75,000 that had no diagnosis. So that's pretty large number there. And then everyone else broke down to this filled out 3-way Venn diagram here. So some of them had COPD, some had chronic bronchitis, and some had emphysema. And some of them had a variation of different amounts. So all of that information is in here. We're going to use that information to start figuring out the answers to our questions here. So how many people surveyed were diagnosed with all 3 lung diseases? Okay, so this is just a straight reading off the graph, so we're looking for all 3 of them are overlapped, and that's this 333 in the middle there. What is the probability that a person selected randomly from the individual surveyed, so that's everyone, was diagnosed with all 3 lung diseases? So remember, anytime we're doing probability, it's what we want or what we're looking for, divided by total options. So we said there were 333 there were 333 that had all of them. So I'm going to divide that by my total number, which is that 75,000. Okay, and then pull out our calculators here because it's an awful odd thing to try and calculate. So we got 333 divided by 75,000, which gives me a very, very small percent, which isn't surprising, of 0.44%. Okay. Remember, you're going to get, the decimal is 0.0044, but if I'm converting to a percent, I do need to multiply by 100 there. All right. How many of the people surveyed were diagnosed with both COPD and emphysema? So we look for our blue and green ones overlap. So careful that you don't just say 343, right? That's how many were diagnosed with these two, but not bronchitis. They just said how many were diagnosed with both, so we need both of these two numbers. So we end up with 676. Okay. Alrighty. All right, so I need to flip over to my next page here. What's the probability that a person selected randomly from the individual surveyed will be diagnosed with both COPD and emphysema? So this is going to be the same setup. We're going to take that 676 from the last problem divided by 75,000. Jump back to our calculator. 676 divided by 75,000. And we get 0.90%. So still pretty small, but almost double the size of our last one. A little over double, actually, the size of our last one. How many of the people surveyed were diagnosed with chronic bronchitis and emphysema? So jumping back over here, chronic bronchitis and emphysema. So I'm using these two numbers, so 333 and 80. So in this case, we're going to add those up and end up with 400 and... made a brain fart. 413. Okay, and what's the probability of the selected person anywhere in the survey had both of those? So take our 413 divided by 75,000 again. And we get 0.55%. How many of the people surveyed were diagnosed with COPD? So that's this entire circle here. So it doesn't matter if they had anything else or not. It's anyone who is diagnosed. So I have to add all those up. So 970 plus 459 plus 333 plus 343 for a total of 2,105. All right, given that a randomly chosen person from the survey was diagnosed with COPD, what's the probability that person was also diagnosed with chronic bronchitis? This is very careful. Anytime you see the word given in a probability, it means we're probably going to be doing something a little different. So that's a very key word. If you ever see it, stop for a second because you're probably going to be changing up what you're doing. So in this case, it says, given that a randomly chosen person from the survey was diagnosed with COPD, that means I'm no longer concerned about any of these other numbers. I'm just looking at that blue circle. That is now my entire world for this question. Okay. So what is the probability that, given that, the person was also diagnosed with chronic bronchitis? So looking at just this circle, how many people had chronic bronchitis? So that's this overlap. So I'll go ahead and add those together quickly. So I have 459 plus 333 for a total of 792. And this is the part where a lot of people make a mistake. What am I dividing by? Okay, I'm not dividing by 75,000 anymore because my entire world is just that blue circle. So how many people had COPD? 2,105 is my new division. Okay. So 792 divided by 2105 gives you 37.62%. So if I know someone was diagnosed with COPD, I have about a 37 or almost 38% chance that they also have chronic bronchitis. Okay. How many of the people surveyed were diagnosed with chronic bronchitis? That's my yellow one, so I just need to add all of those numbers up. So 459 plus 33 plus 80 plus 2071 for a total of 2943. Because it didn't ask for a probability, just said a straight one. Given, pause for a second. All right, given that a randomly chosen person from the survey was diagnosed with chronic bronchitis, so it's one of these 2,943 people, what is the probability that the person was also diagnosed with COPD? So that's once again looking at our overlap here. Okay, so we said there were 792 people here, but I'm dividing by a separate number now because instead of knowing they were diagnosed with COPD, I know they were diagnosed with this, which is more people than were diagnosed with COPD in the first place. So that's dividing by this. All right, so 792 divided by 2943 comes out to 26.91%. Okay. So anytime we deal with givens, it's always the overlap, or the and, if you will, divided by what you were given. So it says given that the person was diagnosed with chronic bronchitis, so it's always going to be the overlap between the two things they gave me, in this case chronic bronchitis and COPD, divided by the one that was given, so divided by the amount of chronic bronchitis. We're going to look at those more when we get to the, word escaping me, frequency tables, which is coming up shortly. The givens show up a lot more there, but just as a general idea, that's how those work.